So for those of you who are here, welcome back. Yay, spring break. I hope everybody enjoyed most or all days of said break. I know it seems a little bit rusty. For those of you who I had a chance to speak with just a little bit ago, it looks like it's just you, Drew. How long did it take to shake off the cobwebs? A little bit, a lot of it? A little bit. Yeah, I think that's not a bad place for us to start. I know we may want to jump into doing the problems, but at the very least, since it's been, for many of you, 9 days since you've even thought about this, that it may be not so fresh on your mind, although you are the people who are here now, and knowing some of you, you are the people who would have thought of this in the past 9 days. You're not the chasers in here. You're the leaders. So that doesn't mean we shouldn't still have a little bit of review there. So I want to go through a couple steps of the process. All right, cool. A couple steps of the process of things that we're going to go through, because we're also going to end up seeing something we haven't seen before, and that thing we haven't seen before is going back from a problem where we start with a proportion and work towards a raw score. But in general, we got one of two directions, and both of those directions involve using a z-score. Let's use the black for this. There, z-score. What's z stand for? Z stands for what? Standard score. So this is our standard score. And we got to be able to convert things to a standard score. What's something that we can convert to a z-score or a standard score using the formula tip?
A raw score.
Yeah, I can convert a raw score to a z-score using formula. What formula is that? How do you calculate a z-score? Tiffany?
X minus mean over standard deviation.
Yeah, x minus mean over standard deviation. Welcome, welcome, welcome. Watch your steps on the chords. If you're not familiar with what chords are, because you were born inside of the 20th century, that's all right. It's the thing that wants to trip you. We're just reviewing, shaking off some of the dust, since it's been a while, since many of us have had a chance to look and think about that. That way, for all the stuff we do today, we can have access to things we need to know. Well, raw scores can be converted into z-scores using the formula. Now, z-scores I can convert to an area, provided I know the shape of the distribution. And which shape distribution do we care about for Module 7? What's the shape of the distribution? Don't tell me, because you're Quinn. Yeah, normal distribution or a bell curve. Normal distribution or a bell curve, if it's given to us in the problem that it says it's a normal distribution, then we can use a z-score table which has a normal distribution on it. So given that we have an area for a normal distribution, we can go from a z-score to an area using this here table. And lastly, we got to be able to use whatever areas our table can provide in order to come up with a proportion, probability, or percent that may be asked for in the question. So in the question, it might say what probability or what proportion. Remember that what is the destination? In this case, if it says what proportion falls between two values, proportion is the destination. So we're going to start from our raw score, whatever that raw score is. In some cases, we're given raw score or scores. We got to get greater than, less than, between those two, and we'll end up with a proportion. Watch your step there. Somewhere between, we may be given a proportion. Watch your step there too. All right, just stop walking.
Yeah.
Cool. You may be given a proportion, and you have to work towards. Can you slide down this way just a little bit? I'm streaming that. I don't want to stream back.
Oh.
No, appreciate that.
You're just like really causing problems.
No, you're not. I cause problems. You have to solve them. But in order to get from the areas that we may get from the table to the proportion which is asked for, we're going to have to draw the picture. And normally in these problems, you will be given 3 pieces of information. You will be given the shape of the distribution, oftentimes a normal distribution, at which point you know you can use the z-table. You'll be given a mean and a standard deviation. The mean and the standard deviation will help you calculate the z-score for some raw score. So given some raw score, mean and standard deviation, you can convert it to a z-score. Take that z-score to the table, get an area, put that area on the picture, which you have drawn. Use that picture to calculate what proportion or probability is being asked for. In some cases, you'll be given a proportion or probability. Put that on your picture. Once it's on your picture, determine what part of the area that my table can provide does my picture say I should calculate. Then you take that area to the table, figure out what z-score it is, put that z-score into here along with the mean and standard deviation that you provided. Solve for x. By the way, if you're going from right to left as opposed to left to right, this is really a left to right formula. You want to go right to left. You can do a little bit of algebra here, multiply times sigma, divide by z, add mu, so that you can say that x equals, because you want to solve for that, z times mu, there's mu over there, say mu plus z times sigma. Make sure I did that algebra right. Algebra in your head is not the way you're supposed to go out. Algebra in your head is not good. Z equals x minus mu, therefore z sigma x minus mu. I add mu to both sides. Z times sigma plus mu equals x, otherwise known as x equals mu plus z sigma. Hey, cool. Same thing. That's what we're working with. We'll come back to this. Cool, we got a little bit of a quorum. For those of you who haven't had a chance to formally greet, welcome to see you. Happy to see you back. Let's start working on problems, shall we? Some of these problems. Zoom in just a little. Some of these problems, let's notice, have 0 points in the points column. They're questions that I don't think are good for doing assessment, to find out whether or not you know the material, but I do like to be able to talk about them still in some sense, so I'm going to include it there. I know, it seems weird. I'm asking you to answer a question, and I'm not going to give you points for it. It means I still want you to be able to think about it and talk about it. Don't get bent out of shape if you can't get exactly the right answer. That's something I have been telling you since early on, is that in statistics, it's not always cut and dry the way things go. So let's at least have the discussion about it so I get you thinking about what these concepts mean. Question 1 out of 47. Does the shape of a normal distribution depend on its standard deviation? The way it's asked here, the actual shape of a normal distribution depends only on its standard deviation. Always, sometimes, never. It's sort of a true-false question. What determines the shape of a normal distribution? Anybody got an idea? So let me sell you on this idea. If a distribution had no variance, variance equals 0, what does its standard deviation equal? Variance is 0, standard deviation is equal to 0. So if a distribution has no standard deviation and it has no variance and it has no variance, it has no variety. A distribution where a histogram, where everything is the same, would look like what?
Flat line.
In fact, it wouldn't be a flat line. That's where our instinct might tell us to go. It's actually the other way around. It's not flat. It may look more like, oh, here's a number of different possibilities. But if everybody said 3, that's 0 variance. That's everything is exactly the same. These 10, 12 people here all said exactly the same thing. No variance, no variety. It's not a flat line. It's a perfectly straight bar. But the more variety I add to it, I start getting away from a variance of 0. Maybe one over here and one over here. Now there is variance because somebody said something besides 3. Variance is still small, but it's not 0 because there are things which are different from other things. Small variance, small standard deviation means your normal distribution is very peaked. We would describe that as being leptokurtic, like leaping. That's how I learned it. Still remember it. It's not a vocabulary term you got to use in your brain, but it's just the idea that a distribution with little or no variance is very narrow. If there's a lot of variance, a lot of different values, oh heck, now we're going to get into the zeros. We still have something that's a normal distribution, but it's much flatter. There's a lot more variety. The more variance or variety, the higher the standard deviation, and the flatter our normal distribution is. The more variance, the flatter, the less variance, the narrower. So when it comes to determining the shape of a normal distribution, depends only on its standard deviation. Well, there's 2 things we need to know about normal distribution. It's the mean and the standard deviation. So the standard deviation is the only thing that determines the shape of that normal distribution, at least in terms of how narrow or how wide it is. It's not worth any points, but you can put always. I want to have that discussion. But for question 2, does the mean of a distribution affect its shape? Does the mean of a distribution affect its shape? Who says yes, the mean affects its shape? Who says no, the mean does not affect its shape? I see some more hands for that. Kyle, what do you think? Why'd you say no?
Well, because we just said that standard deviation is the only thing that affects the shape. So.
I appreciate using evidence of things you just learned. Yeah, no, that's good.
I don't really know why. But that's,
Well, see this picture right here?
yeah.
What's the mean of this distribution?
They're around 3.
3. Yeah, this is the mean. If it's normal and this is the mode, it's also the median, it's also the mean. The middle of the normal distribution at central tendency is this many, 3. What happens if I just add 10 to every number? And that's actually 10, 9, 8, 7, 16. Kyle, has the shape changed?
No, sir.
Has the mean changed? Yes, it has. The mean went from 3 to 13. Shape hasn't changed. The central tendency doesn't affect the shape. When it comes to a normal distribution, the only thing that affects its shape is the standard deviation. So you can put never there, but it's not worth any points. It's mean and its standard deviation. Here's an and or question. Well, its shape is not determined by its mean. Its shape is determined by its standard deviation. So whether we want to get back down into the quagmire of and or, come on, question 3. The actual shape of a normal distribution depends only on its mean and standard deviation. It would depend on either one of those, but not both. So I would say never here. If it's not worth any points, don't worry. As long as you can walk away from this discussion, this is the abbreviated discussion since it's pace time. Walk away with the discussion that a normal distribution can be narrow or flat. And the narrow normal distribution is narrow because it has a little variance. And a flat normal distribution is flat because there's a lot of variance. You walk away knowing what I want to know. You walk away knowing what I might ask. That a flat normal distribution has a high variance, but a narrow normal distribution has a small variance. You got that one? Megan, you got that? You gonna remember that one? Why are you gonna remember that one?
We said it a lot. Very common.
So,
So, it's probably not a test.
I didn't say that.
You did not.
I did not say that.
Can
Katie.
you repeat the second part?
Sure. A narrow normal distribution has a small variance. Can't remember which one I said first.
Yeah.
Yeah, but I say variance and standard deviation interchangeably here because I'm just talking about in terms of big or small, and variance sounds better. It has fewer syllables and it sounds more like variety than standard deviation. Cool. All right, let's start running then because we have 44 more to go. And we can at least talk about things we know the answer to, catch some of that low-hanging fruit, and then we can move forward from there. I know we're not doing the hard stuff first necessarily. But hey, 4 out of 47. The normal probability distribution is skewed. Who says never? Who says sometimes? Who says always? Nevers have it. Property of the normal distribution is that it's symmetrical. The whole reason we care that it's symmetrical is so when we use those z tables, we can use either a negative or positive z along with our own table. Question 5. The normal probability distribution is symmetrical. Who says never? Who says sometimes? Who wants them always? Always is correct. It's always symmetrical. Now remember, we've seen data which we have described as it's normal enough. That's not what we're necessarily talking about here. When we're talking about the normal probability distribution, we're really, this may be the standard normal distribution. This may be the standard normal distribution. The standard normal curve. But as we're talking about many of these here, normal probability distribution will be symmetrical. Hey, normal probability distribution is bell-shaped. Who says normal is always bell-shaped? Make sure you click the middle one because that's where it says always. Unless always is not in the middle for you. Is always in the middle for all of you? Yeah, all right, good. 6 down, 41 to go. Let's add a little more here. Hey, ooh. The normal probability distribution is an asymptotic family of curves. Asymptotic. Asymptotic. What's asymptotic mean? Steve?
The line doesn't touch the x-axis.
Doesn't touch the x-axis. I like that. I like that. What's an asymptote? That's what asymptotic has to do with. It has to do with asymptote. Y'all know asymptotes a little bit? Can't see it because it's bright in here. I'm not used to staring at the sun. Haven't spent the past week in Puerto Vallarta. Steve, right about this never touches thing. What's this never touch thing mean? Give me a little more. Give me a little more than what Steve. Anybody add on to that? Curry.
Line that continually approaches a given curve does not meet finite distance.
Yeah. Steve, is that what you said?
You summed it up better.
Well, I don't know if he summed it up. No, you didn't. Thanks, Curry. Good to see it. So an asymptote, exactly as both Stephen and Curry described, if you look at our particular normal distribution that's drawn here, it really does look like that's an intersection and that's an intersection. But in actuality, this line just continues off infinitely, and the x-axis that Steve was referring to, these two things never come into contact. Never, ever, ever, ever. So, I mean, I guess if we just want to answer that question, true or false? Ooh, what do we mean by family of curves? Family of curves is the other part. So if we understand that the normal distribution asymptotic. What do you mean by family of curves? Katie?
Like, probably more than one.
Yeah, probably more than one. Can you describe what two normal distributions, which are similar because they're both normal distributions, what they might have different about them, such that we might say they're both the same because they're normal, but they're different because of something else?
Well, that's not different from the y-axis.
How would the different from the y-axis part be? What's another thing that might help me tell that story?
Shape.
Shape. Caitlin, is that where you're jumping in?
I was going to say that mean. If they have the different.
Absolutely. They could have different means. What else could they have different? You said the S word? Yeah. Shape. So if we want to talk about a whole family of curves, well, here's a normal distribution. And here's another one. Those are both normal distributions. I know one is green and one is black, but what would you say about their shape, about their standard deviation? Do you think their variances are similar or different? Katie, what do you think? Yeah, I bet since they both sort of look the same, but maybe one is over this way and one is over that way, maybe the only thing that's different between the two is the fact that they have different means. Because I could also draw one in blue and say, here we go. I have a third one. This very leptokurtic curve has the same mean as this one here. However, its shape is quite different. All of those are normal curves. Some of them have different means. Some of them have different standard deviations. The normal probability distribution is an asymptotic family of curves. That's true. That's always. That's yes. 7 down, 40 to go. Questions to this point? Let's get through the vocab right now so we can start working on Rob and Rachel. 7, the normal probability distribution is uniform. Who says always? Who says sometimes? Who says never? Who abstained from all that voting, like good college students that you are? I know they teach you abstinence, but when it comes to voting, you should participate. Who says always? The normal distribution is uniform. Who says sometimes? Who says never? All right, never is right. Why is never right? All right. Here's how I'm going to do it. Normal distribution, I spelled it wrong, but it shows me a bell curve when I Google it. I can type uniform distribution. I may have spelled it right. But a uniform distribution is known as a rectangular distribution. It is a flat distribution. A uniform distribution is not normal. A uniform distribution would look more like this. It is flat. So that's 8. Hey, now let's start talking about problems. So from here on out until we get to the end, so not here on out, from here on until a while, we're going to be working on math problems. We're going to be working on math problems that do go back to this stuff. So rather than spending my time switching back and forth, I've got some printed out here. So at the very least, we can come to this, just look at the problem, and we can stay on paper here. Any questions before we start talking about Rob and Rachel? All right. For those of you who are studying for the midterm exam over break and asked me about answer keys and asked me about a number of different things, that's great. And for many of you, I told you the answer key, I mean, for anybody who asks, that the answer key is not going to be available because I don't like to provide those, et cetera, et cetera. However, when it comes to how you can expect to prepare for your final exam or your midterm exam, I think it's really useful to be able to look at questions like this. Talking about Rob and Rachel here, and being able to identify particular parts of, let's say, your vocabulary terms. So here's a passage for number 9. Is this 9? The Camp family has twins, Rob and Rachel. Both Rob and Rachel graduated from college 2 years ago, and each is now earning $50,000 per year. Hooray! $50,000 per year. Rachel works in the retail industry where the mean salary for executives with less than 5 years experience is $35,000. What symbol do you associate with $35,000 in this context? So it's going to talk about the mean, Drew. Yeah, we're talking about the mean. So this could be a sample mean. It could be a population mean. And the types of problems that you're going to see for your midterm exam, I may say, from a sample of executives with less than 5 years experience, I determined the mean salary to be $35,000. If I say, based on a sample of executives with less than 5 years experience, the mean is $35,000, what symbol would you use for the mean? Joe?
X bar.
X bar. And that's how you should read these problems. In a problem like this, you're not given whether this is a sample mean or a population mean. Generally, if it's declared to you as the mean salary is, think of it like that. Like it's population level, it's truth level. It's not based on some sample. It's some omniscient person who happens to know everything about all salaries everywhere says, you know what? The mean salary for this position is $35,000. Therefore, here, where it says the mean salary is whatever you see here, the mean salary, that's mu. In that case, mu is $35,000. And I also see here the mean is $35,000 with a standard deviation of $8,000. I know standard deviation equals 8K. What symbol should I use for standard deviation given this context? Steve, you say sigma. Why do you say sigma?
Yeah, that's the symbol for standard deviation.
That's a symbol for standard deviation. It could be sigma, it could be x. We got to decide which one. So here's a way we can get used to reading this too. This is absolutely something that helps you down the line, helps you on your midterm exam too. Again, if it's not told that it's provided by a sample, it's probably population level. In this problem, I don't say I sampled a bunch of executives and my sample standard deviation was 8,000. What I'm told here is the mean salary is 35,000 and the standard deviation is 8. If I'm using mu, I'll probably use sigma as well. Sigma equals 8K. But we also have Rob. Rob is an engineer. Rachel works in the retail industry. What is Rob's raw score? What is Rob's salary, his raw score? Drew? 50K. What's Rachel's raw score? 50K. They both have the same raw score. They both make the same amount of money. But in one context, Rachel's context, the average is 35K. In Rob's context of being an engineer, what's the mean salary? Say that? 60K. Is Rachel making more money than her peers? Curry? Yeah. How much are her peers making on average? How much is she making? Good. Is Rob making more money than his peers? No. How much is Rob making? How much are his peers making? Good. He's making less. She's making more. Now we got to come up with a z-score for Rob. We have mean salary here is 60K. That's for engineers. And a standard deviation of $5,000. So we've actually got two different means, two different standard deviations, and two different raw scores. Well, the raw scores are both 50,000, but in one case, that 50,000 corresponds to the retail industry. In one case, the 50,000 corresponds to engineering. When you read your midterm exam vocabulary questions, some of them will involve context like this. And I suggest that you look for words like the standard deviation of the sample was 10,000, 5,000, which would indicate the appropriate symbol is S because it's the sample standard deviation. But in a context like this, where I haven't told you, I sampled 100 people in the engineering field, and well, I determined from that the standard deviation is 100 and the mean is 100,000. There's nothing in here at all about me taking a sample of anything. If there's nothing in here about me taking a sample, it's probably population level. That's a lot of work to answer the question, but answering the question is pretty straightforward, I think. Who's already got the answer to this question laying around? Joe, tell me what the answer is.
I -2.
How'd you get -2?
So I took the value X, which is what he's making.
Yep.
And then I subtracted 60 from that, 60,000.
Okay.
And the standard deviation was 5,000.
Okay. Let's drop some zeros. Looks like we got 50 minus 60 over 5. 50 minus 60 is 10. 10 divided by 2 is, sorry, 10 divided by 5 is 2. I don't see 2 though, Joe. Because 50 minus 60 is 10. 10 divided by 5 is 2. But I don't see 2. I see -2, but I don't see 2.
Should be -10.
Yeah, it should be -10. Z-scores have 2 parts, distance and direction. You're exactly right, Joe. You did it right. I pretended to mishear you so I could emphasize the point. Thank you very much. Appreciate it. Yep. 50 minus 60 is not 10. 50 minus 60 is -10. Z-scores have distance and direction. In this case, the direction is negative because, as Curry pointed out, Rob is making less than his peers. So his Z-score better be negative because it represents less than average. Okay, answer key D. Yeah, that's also this new format here, so we can also see what the, I don't know, how far back can you see this? Jack, can you see it says answer D? Yeah, so now you actually know what the answer is. At least what it says in the key, so we can try to avoid that stuff. Questions on 9? 9 down, bunch to go. Moving up the pace now that we're talking about Rachel. Same context as before, but the mean and the standard deviation is going to change. Rachel makes 50,000. The average for people in her industry is 35,000. Standard deviation is 8,000 for her industry. So in order to calculate Rachel's Z-score, by the way, 50K, 35K, 8K, I'm just getting rid of K's. Same way I got rid of K's up here. 50 minus 35 is 15 over 8. What's 15 over 8? That's our Z-score. So what?
1.88.
That number? Yeah. I hope there's other options on the next page. There are, but we don't need them because the answer is A. 1.88. Calculate Z-score. 10 down, 37 go. Questions, comments, concerns, thoughts? Kurt, yes, sir.
Will we be asked to use the mean of probability distribution and mean of binomial distribution formulas
On the midterm, I may give you a binomial probability experiment and ask you to calculate the mean or expected value of it. Yeah. I don't know that we're going to do a whole lot of integration of this and that, except for what I had mentioned, bridging between modules 6 and 7. The idea that when we have the binomial probability table, you know, X with the raw on the 0.1, 0.2, 0.3, we can use complement rule and add up and subtract probabilities and stuff. And that's really what we're going to be doing when we get into the next problems in this section. But I'm not going to ask you, like, here's a binomial probability distribution, now start doing Z-score stuff with it. No, not that. No, let's do those. Other questions, comments, concerns, thoughts? Pace check. Too slow. Just right. Too fast. Too slow. Just right. Too fast. All right. No one said too fast. We were split about 50-50 on too slow and just right. So I'm going to move the pace up just a little bit. I'm kind of bored now. I'm not bored. I just know that our next problem, number 11, is asking what's the Z-score here. So a recent article in the Cincinnati Enquirer reported that the mean labor cost to repair a heat pump is $90 with a standard deviation of 22. Monty's Plumbing and Heating Service for complete repairs and 2 heat pumps this morning. The labor cost for the first was $75, and it was $100 for the second. Assume the distribution of the labor cost follows a normal probability distribution. What's the Z-score for 75? How do you calculate a Z-score? How do you calculate a Z-score? Katie?
X bar minus mu over sigma.
Rushing the gun a little bit. It's not X bar yet. It will be eventually, but currently it is not.
So it would be 75 minus 90 over 22.
What's that get you?
Negative 0.68 or 2.
Yeah. I gotta believe that negative 15 over 22 is something less than 1 and negative. So it's gonna be that one. So I say right now, in the future, when I ask you what a standard score is, the answer is going to be sampling error over standard error. Sampling error is X bar minus mu. But we're not there yet. Eventually, our Z-scores will be that. But right now, it's just raw score minus mean over standard deviation. 12.1.2. A recent article in Cincinnati Enquirer. We don't care about Cincinnati. Hey, what's the Z-score for 100? X minus mu over sigma. How do I do this one? I need 3 values and a bit of arithmetic. Tiffany, please.
100 minus 90 over 22.
100 minus 90 over 22. 10 22s. It's 5 11s. How many are 511s?
0.45.
Sounds good to me. (1313), we're calculating another z-score. Who's comfortable calculating z-scores? Good. I see a lot of hands for comfortable calculating z-scores. In the interest of time, does anybody want to pretend like we did all these z-score problems? If it's just calculating a z-score, we skip it and move on to the more tougher stuff? Rhymes with Katie says, yeah. Colin gives me the thumbs up. Drew's listening to Metallica. All right. So for the rest of these, for example, if you have a mean of 12.2, a standard deviation of 2.5, and by the way, why do I know to use mu and sigma in this problem? Something should indicate that curve.
Population.
What population?
Normal population.
Yeah, the third word of the sentence says population. If the third word in the sentence says population, use mu and sigma because those are population parameter symbols. X is 14.3. 14.3 minus 12.2 over 2.5 looks something like 2.1 over 2.5. Gosh, probably something around a little bit more than 1. No, a little bit less than 1. That's a little bit less than 1. Cool. At this point, what proportion of the population is between 12.2 and 14.3? Now we actually have to start doing some of this math, so we don't get to fast forward through anything. But we did calculate the z-score, and that's going to be useful for a problem like this. Problem like this, I see what proportion. Therefore, proportion must be the destination, and I have to start with some raw score. I already know that can't be the answer. Why can't negative 0.2995 be an answer? Caitlin?
They have a negative proportion.
Can't be negative. This part of what the answer can't be negative. Nope. How do we answer a question like this? When we go back to some structure, we see like here. We need to draw a picture, convert raw scores to z-scores, turn those z-scores into area using this table. And then once we have a picture, we can turn that stuff into gold. Gold is at an all-time high. It is not. Gold is actually on its way down. So, in this problem, we are told that the mean is 12.2. The standard deviation is 2.5. And then our distribution is normal. And I already have the z-score, 14.3. We determined the z-score in the previous question to be 0.84. So if x is 14.3, its z-score is 0.84. Draw the picture. Is the scrap paper distracting? Should I be using clean white paper? We good? All right. Just trying to hug the earth. In the middle of our normal distribution, a raw score of 12.2, because that's the mean. The z-score. What's the z-score for the mean?
0.
When? You sure? Good. Z-score for the mean is always 0. You can be sure. I know that if I have a raw score on here of 14.3, it has a z-score of 0.84. And the question I'm being asked in 14 is what proportion is between 12.2 and 14.3? So what I need to know is what that area is, otherwise known as POW, what that area is. Same thing. The z of 0.84, I come back to my concepts. I've taken that raw score of 14.3, use the formula compared to a z-score of 0.84. Now I got to take that z-score of 0.84, and I got to take it to my table. How do I use this table to find an area? Someone walk me through that, please. Caitlin, yes, please.
For 0.8, so you go down to 0.8 on the Z and then over to 0.04.
Down to 0.8. 0.80, 1, 2, 3, 4. 0.2, 9 or 5. And for this area, right here is 0.2995. Now the last step here says look at that area, go back to the picture, and tell me what the proportion is. The proportion is 0.2995. It's a trivial step in this case. In some cases, we may need to add or subtract from 0.5. We may need to add or subtract one piece from another. Having the picture there helps us to know which parts we need to add and which parts we need to subtract. But for this problem, it's pretty trivial, because we can just look at this picture and know that the area between those two things is the same as the proportion we're looking for, or 0.2995. Hopefully, that's an available option here. Cool. See? We're going to do another problem given the same scenario, and that's the one that comes up next. Questions on 14? All right. I may be doing less of do you have questions on this, and I want you to stop me, because know that your midterm exam is going to require you to do that stuff. But I do want to pace it up a little bit because we got a whole bunch to go. And I'm already losing my voice. But hey, check this out. We're going to do the same thing in this problem that we just did. We have the same context. That context says we have a mean of 12.2, a standard deviation of 2.5, and one other piece of information. What one other piece of important information is given to us in this problem? Very important piece of information. Yes, sir. Normal distribution. It's a normal population. Because it's a normal population, I can draw a normal curve. It's a very bad normal curve, but it's still got 12.2 in the middle. I need to know what proportion. So my destination is going to be proportion. I better be given some sort of raw score. Am I given a raw score in this problem for the question part? What raw score am I going to use for the question part? Column. 10. Very good. So I need to convert that 10 into a z-score. Z equals 10 minus the mean, which is 12.2, divided by the standard deviation of 2.5. I get something like, let's see, all right, 10, by the way, should be over here. That's our raw scale. 10 minus 12.2 is 2.2, divided by 2.5. And I get, what's 2.2 divided by 2.5? I don't have a calculator. You guys always have your phones in your hands. That's just me being an angry old man. Trust me, I had my phone in my hand so often this week, my mom was very upset. How much? 0.88. So my z-score must be 0.88. Correct? No. Why not? It's not an option. Well, we're not looking for z-scores here. We're still looking for proportion. We're only part of the way there. The only part we've done right now is taking raw scores to z-scores. But my z-score shouldn't be 0.88. What's wrong with this problem? Curry, what's negative? Your attitude? No, it's not. Your attitude's been great. Your attitude's positive. You can say no. Is your attitude negative? No, it is not. What should be negative? 0.88 should be negative. Why should it be negative? Yeah. Remember your signs on that. Gotta remember your signs on that. Z-score for the mean is 0. Unlike Curry's attitude, the z-score is negative. But now I need to use that table because I have a z-score now. I got to go to the table to get an area, and when I go to my table and I look up 0.88, sorry, negative 0.88, because Curry pointed out it should be negative, I don't see negative 0.88 on here. My table's broken. Math is hard. I give up. Right? What else can I do? Who's a problem solver in here? Who's a game changer? Katie?
So you go to Z 0.8 and then go over to.
But Z's negative.
It doesn't matter if it's symmetrical.
Doesn't matter because it's symmetrical. All right. That sounds good to me. We established that earlier. Now I have evidence. It doesn't matter whether I'm using a Z of 0.88 or negative 0.88. Normal distribution is symmetrical. So it doesn't matter if I use Z or if I use negative Z. It's just fine with me. So what do I do here, Katie? So come down to here where it says 0.8.
Yeah, and then you go over to 0.08.
It's a long walk. Did you get 0.30106?
Yeah.
Sounds good to me. That means this area right here, 0.3106. So my answer, 0.3106. I click B, and I get the answer wrong. Why do I get the answer wrong? I just looked up the area. I see this says 0.3106, and we went through that whole positive negative symmetry doesn't matter thing. 0.3106 is the area I looked up. Why is it wrong? So what, Stephen?
It asks what's less than 10.0.
So what I actually need
Minus.
is this area. This is the proportion I need. Sure, this is the area I looked up in my table. But in order to find what's in the tail there, I need to do some sort of addition or subtraction. By 100. Talk to me, Joe. Tell me some other things I should know about this.
Subtract that from 0.5.
Why 0.5?
Because that's half the area.
It's half the area.
Let's
Let's talk this through. You're right.
To the left of 12.2, that's
Yeah.
half the area.
I thought that was the mean.
Yeah, so
It's symmetrical. What measure of central tendency says half or below and half or above? There's 3 measures of central tendency, and they all start with M. Caleb? Median. I said the mean is 12.2, but Joe's trying to use the mean like the median. Is that an okay thing to do here? No distribution, so they're all the same. Yep. That's a good justification for me. The entire area to the left of my poorly drawn normal distribution is 0.5. I subtract 0.3106. And I'm left with hopefully something around 19%. Circle gets the square. This is a case where the picture is non-trivial. In the previous answer, we just needed to get this chunk. That was easy. But in this case, we got to go less than a certain one. The picture, not trivial. $15 down. Whole mess to go. Questions, comments, concerns, thoughts here? Let's do the next one. Thank you, Abby. You want to be my producer, keep me going, make sure we cover what we need to cover?
We love you.
I would love it too. I need some of that. 16. A recent study of the hourly wages made to crew members for major airlines showed that the mean hourly salary is $20.5 with a standard deviation of $3.5. Assume the distribution of hourly wages follows the normal probability distribution. What's the probability that a person selected at random makes less than $19 an hour? We're going to go through the same steps here. What's our destination? Are we working towards a probability or working towards a raw score? Working towards a probability, because the question part of the question says, what is the probability? So probability is going to be my destination, and I got to start with raw score. Is there a raw score that's going to help me get to a probability? If so, what? True. $19. Yep. There are 3 key pieces of information here. We say that the mean hourly salary is 20.5. We say that the standard deviation is 3.5. Do I have anything in here that indicates the shape of this distribution? Normal distribution. Danger, do you see that up there? Yeah, normal probabilities. If you had to guess whether these would be population level or sample level bits of information, $20.50 is a mean, $3.50 is a standard deviation. Do you think those would be population level characteristics or sample level characteristics? What do you think? Mike, what do you think?
I think we sample because it's a recent study, so I'm guessing it's a small population.
Oh, except for that last word. Yeah.
Not a population, sorry, just sample.
Yeah, exactly. And I really like that. Very well inferenced. I would call this sample level information because it comes from a study. It doesn't tell you how large the study was. It does tell you it was recent. It says in a recent study. So I assume that we went out and talked to a bunch of people who work for the airlines and asked them how much money they make per hour. It's not as though we've done an audit of all airline professionals everywhere. But we're still left with the same important piece of information here, which is that X bar is $20.50, that the sample mean, or the sample standard deviation is $3.50, and we have a normal distribution. So let's draw a normal distribution with asymptotes. And in the middle of this normal distribution, we're going to put the mean, which is 20.5. It has a z-score of 0. I got to put the raw score of $19 up there somewhere, left or right, left or right. Which side, left or right? Left. Thank you. I need to be able to convert that raw score of 19 using this formula, otherwise known as x minus x bar over s. Same thing. Get a z-score, go to the table with that z-score, get an area. Looks like this is the area that we're going to have. But the question is asking, what is the probability the person selected at random makes less than $19 an hour? I have 3 areas. I have A, I have B, I have C. Those are 3 different regions there. I have A, I have B, and I have C. Which one of those is going to be the answer to the question? A is going to be the answer to the question. B is the area that we look up in the table. B is not the answer to the question. A is the answer to the question. How do you suppose we find A, given the fact that this area is the one we look up? How are we going to do that? Joe, how did we do it before? How did we get the tail before?
Subtract it from 0.5.
Exactly. We know that this entire area here is 0.5. So it's going to have to be some area less than 0.5. Won't be negative, won't be negative. Too big, too big. It's got to be either that one or that one. Let's figure it out. What's the z-score associated with this? We got to take a raw score to a z-score. We take 19, subtract 20.5, divided by 3.5. Beep, boop, 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 boop. I want to say 42. No, that's not a decimal, but it's close. What are we in here? What's the z-score here? Bert? 2 decimal places? What did you tell me it was?
0.42. 0.43.
We're around that to 0.43. What is it? 0.427 and change, I think. I don't know, man. Something off about that z-score. Thanks, sir. You stay positive. Let z-scores be negative. Now that I have a z-score, I got to take that z-score to the table. And remember when you're looking at these z-scores, so 0, negative 0.43. This first part, 0.4, that's what determines the column. Sorry, that's what determines the row. And then this part right here determines the column. Z is 0.4012. A z-score of 0.43. One, 6, 6, 4. So then I fill in 0.1664. No, why not, Steve?
Subtract that by 0.500.
Yeah, we gotta subtract it. We get something on the order of 0.3336. That's our answer. Not that one. Answer's A. How we doing?
All right.
Moving forward? All right, let's do it. 17. The mean of normal probability distribution is 400 pounds. Standard deviation is 10 pounds. What's the area between the mean and 395 pounds? 3 pieces of information here. Normal probability distribution. The mean is 400 pounds. Standard deviation is 10 pounds. I would go ahead and say that's probably population level stuff because it didn't say it came from the study or sample. But normal distribution? Come on now. Normal distribution? Sort of like that. For the raw mean, 400. What's the z-score for the mean? What's the z-score for the mean?
0.
When? You sure? Yeah. Do y'all know the z-score for the mean is 0 always? All right, let me know next time and I won't ask you again. It's now next time. What's the z-score for the mean?
0.
When? You sure? Good. Thank you. I had a raw score in here of, oh, I skipped, we're on 17, not 18. Not this one yet. We're here. Between the mean and 415. So somewhere over here, 415. That can't be an answer. That can't be an answer. Anybody have a guess based just on the answers that aren't given by the key? All right, let's ignore the fact that they're giggling. I eliminated 2 because they're negative. What's another value or values I can eliminate to answer what proportion are between the mean and anything else? Between the mean and anything else has a limit. Between the mean and infinity has a limit. What's the most area you can have between the mean and anything else? Colin. So which 2 should I eliminate here, because the question's asking about between the mean and anything? F and? How about Bravo? We're going to eliminate those 2 because they're both greater than 0.5. So our answer has to be one of those 2. Let's figure it out. You've got a raw score of 415 and use the formula to get a z-score. We're going to help Kyle back in the room because he doesn't know how to pick locks. You betcha. What's the z-score for 415? $15 over 10. Tiffany? 1.5. Positive or negative? Yeah, better be. It's on the right-hand side. Now I have a z-score. I've taken that raw score of 415, use the formula to get a z-score. Z-score to the table. I better have a z-score here. 1.5 is going to determine the row, and that O is going to determine the column. The z-score of 1.5, we get an area of 4.332. We go to the picture. Well, that area is the thing we need. There's our answer. Questions, comments, concerns, thoughts? Next problem. Next problem, same scenario. Normal distribution, mean of 400, standard deviation of 10. Now I need the area between the mean and 395. Rather than drawing a new picture, I'm just going to add 395 over here. Doesn't have to be to scale. 395. What's the z-score associated with the raw score of 395? Let me hear your new voice. If you haven't spoke up, just let me know you're here. Katie, you're here, right? What's the z-score associated with 395? Yeah. Appreciate that, Katie. Z equals 395 minus 400 divided by 10. That's negative 5/10, otherwise known as negative 5/10. I have a z-score. I convert it to an area using the table, but my table doesn't have negative values on it. I give up. Math is hard. But what property of the normal distribution allows me to use negative z-score, Drew? It's symmetrical. I come to a z-score of 0.50. I get the area of 0.1915. All right, I believe that's the answer to 18. 0.1915. All right. Hey, same distribution. The mean and normal probability is 400 pounds, standard deviation 10 pounds. Same thing we've been looking at. What's the probability of selecting something less than 395? Do I need to go through all the same steps again? No, Curry, what should I do?
0.5 minus previous answer.
0.5 minus previous answer. All of this is 0.5. This is what I'm looking for in question 19. So I take 0.5 and subtract about 20%, and I get something around 30%. Because it's on the negative side to make the area negative, right? Nope. I was joking. Answer is B, 31%. Good? Good? Just more of that adding and subtracting. Question 20. A normal distribution has a mean of 50, standard deviation of 4. Compute the probability between 44 and 55. Normal distribution. The mean of this distribution is 50. You convinced me that the z-score of the mean is always 0. So I'm going to write 0 there. Two raw scores I got to put on here. With two raw scores I got to put on here. Samantha convinced me that you're here. What two raw scores do I have to make sure are on here? Thank you. How do I compute the z-score of 44? Use the formula. Here's the formula. What's the mean? What's standard deviation? 4. All right. So if I have both 44 and 55 on here, in order to find that z-score, take 44 minus 50 divided by 4. Is that negative 1.5? Seems like negative 1.5. Samantha, do you agree it's negative 1.5? Good, me too. Z-score is negative 1.5. Oh. This z-score is 55 minus 50 over 4. What's that z-score? It's 5 over 4. Tiffany. 1.25, thank you. So in order to answer the question, the probability between 44 and 55, I have to get this area and this area and do something with those two areas. What mathematical operation do I need to use, Megan? Yeah, addition. Good old add. Nothing beats add. It's like rock, paper, rock, scissors. Nothing beats add. I have a z-score of negative 1.5, so if z is negative 1.5, I know that the area, something I can look up. I know that a z is 1.25. I know the area, something I can look up. Z is 1.5, what's my area? Okay.
0.4332.
Come down to 1.50, very good. 0.4332. How about a z of 1.25? Steve, you got that? Yeah. 13944. And probably C. That's all right. Questions, comments, concerns? All right. What about compute the probability of a value greater than 55? Rather than doing this work all again, I think I have everything I need up here. How do I get greater than 55, Caitlin?
0.5 minus 0.3944.
Yeah, take half, subtract that. So I'm going to look for an answer around 0.1. Is there an answer down there around 0.1? There. Easy peasy. By the way, quick aside, for those of you who have spent any time at all working with this workbook that I put together, you can do all the same stuff that we've been doing. The calculator right here. I can input a mean of 50 and a standard deviation of 4, but in two raw scores of 44 and 55, and I can get, is it 50 and 4? and 4. I can get all those things here. 44, 55, between those two, outside of those two, greater than those two. Notice that some of those are a little off in terms of rounding. That's okay. Still gets you to about roughly the same thing. Our answer here on the Excel workbook says 8275. Our answer using the table says 8276. It's the same sort of thing. So if you want to practice doing stuff by hand or using this, you got both options. Uh-oh, probability between 52 and 55. It's the same problem we were looking at before. Between 52 and 55. By the way, notice that in this problem, in this problem, same scenario we're working with for the next problem as well. A normal distribution with the mean of 50 and a standard deviation 4. We always have to calculate the z-scores and then the areas, and then either add or subtract the areas, or add or subtract them from the normal distribution. So you're working with the areas. In problem 22, we're given the same scenario, which is a normal distribution with the mean of 50, but we're now trying to get between 52 and 55. We're trying to get this area here. We already determined in the previous problem that between 50 and 55, which is the z-score of 1.25, this area right here is 0.3994. So this entire area right here, 0.3994. What do I need to do in order to find just this chunk? Just this chunk right here. Talk me through it, Tim.
First you have to find the z-score for 52.
Find the z-score for 52. We always got to take our raw scores. No matter what we're doing here, we can't subtract the raw score. No part of this says subtract raw scores. We take the raw score of 52 and convert it to a z. What do you get there?
0.50.
0.50. That's our z-score. Now what do you want me to do, Tiff?
Go to the chart and then find the area. So it's 0.1915.
0.1915 is the area associated between these two. What shall you have me do with those two areas, Tiffany?
Subtract 0.1915 from 0.399.
That should get me something on the order of 0.2. Rather than do the math, I'll just base it on what I see here. How are we doing? It's all right? Okay. So we got about 40 minutes left. A lot of these problems follow very, very similar patterns. So this next question about American Idol viewers says that it has a mean of 29 million and a standard deviation of 5. Assume that follows a normal distribution. It wants to know what's the probability next week's show will have between 30 and 34 million. I don't think that's all that different from what we've been doing thus far. In the interest of time, if we can, we'll come back. Does anybody not know the appropriate strategy to address this question? Hint. Mu is 29 million. Sigma is 5 million. And we operate under the normal distribution. Normal distribution. Mean of 29 million. Standard deviation of 5 million. Assume this follows a normal distribution. Same stuff. Here's my question. If I want to know the probability next week's show will have at least 23 million viewers, what do I draw in my picture and how do I use it? Let's see. Lauren, can you prove to me you're here?
How do you draw it on the
Yeah, what do I need to do to answer this question? Yeah, you should tell me through. Okay, so 23 is less than 29, so I draw a line here.
And then find, you're looking for the amounts less than the 23.
You're looking for something
Oh
over
wait,
here?
I mean more than, sorry, I can read the least.
Yeah, at least 23 million
Yeah.
means I need all that nonsense. So assuming I find this area in here, what do I add or subtract to that area in order to find my answer?
You'll add the z-scores of the amount between 23 and then the, I don't know if you all.
Maybe a little bit. Caitlin's going to help us though.
You have the z-square between 23 and 29, and then add 0.5 because the rest of it's a median.
So I'm going to have a z-score here for whatever the z-score is. And I'm going to take that to the table, and that's going to give me an area. An area right here. But I need to add to that 0.5. Because at least 23 million means it could be 23, 24, could be 29 million, could be 32 million, could be 45 million. But if it's at least 23, it's 23 to 29, whatever that area is, plus 0.5. In this question, same distribution, mean is 29. What's the probability that it will exceed 40 million viewers? What's the strategy here? I'm going to convert 40 to a z-score. And that z-score is going to give me an area. And that area is this area right here. What do I need to add or subtract to that area in order to get the right answer here? Lauren, you got this one?
We need to subtract the amount that's more than.
Okay. So tell me a little more. Once I find this area, it's just a little mathematical operation I need to do in order to find that. Yep, I'm going to find the z-score of 40. And once I find the z-score for 40, I go to the table and get an area. And I'm calling that area whatever I find right here. Once I find that area, what do I need to add or subtract from that area or to that area in order to get the answer, which is exceeds 40 million?
Subtract, well, you subtract that area.
Very good. Subtract that area from 0.5. And whatever that answer is, that's the correct answer for the question.
I have a question from the one before. Would it be able to do like the area to the left of 23 and then do 1 minus the
That would be the exact same thing. So what Tiffany's saying is that if you take this area here and you subtract it from 0.5, whatever this is right here. But that's the complement of what you want. So you can take 1 minus that, and then you'll get your answer. That's the whole point of the picture. This is where we're illustrating the non-trivial nature of the picture step. So if we want to be exceeding 23 million, we know we have to add 0.5. If we want to exceed 40 million, we have to subtract 0.5. Or in the cases Tiffany's describing, we can find out what this tail is by subtracting from 0.5, and then use the complement of it to get the entirety. Now let's get to something that we've seen that's a little bit different. Let me just check here. And this is one of the longer sections. A normal distribution has a mean of 50 and a standard deviation of 4. Determine the value below which 95% of observations occur. 26 is absolutely something new that we haven't looked at. In this case, the question says determine the value. Here, that's our destination. We need to determine the value. We better have been given some sort of proportion or probability in this problem. Are we given a proportion or probability in this problem? Joe, what's the proportion?
95%.
Yeah. The value below which 95% of observations occur is also known as the 95th percentile. What this question is asking is, given a normal distribution with a mean of 50 and a standard deviation of 4, what is the 95th percentile? So we're given those 3 pieces of information. Normal distribution. The mean is 50, standard deviation is 4. So I'm going to draw that picture. And I know part of the question that's asking about proportion says there's going to be some value over here, whatever that value is. 95% of stuff is over there. I've been given a proportion, which is 95%. I have put that proportion on the picture. Now my job is to use that picture to determine an area that I can use in my table. In other words, some part of this picture, I can get an area to look up in my table. Anybody got an idea of what area will prove useful here? Here's my question. If I stand here, what proportion of stuff is to my right? 0.5. 50% of stuff is over here. If 50% of stuff is over here, how much stuff is between those two? Well, 95% of stuff is here. If I get rid of 50%, how much is left? Say 45? Yeah, 45% of stuff. So this area right here, 0.4500. And that's taking the proportion of 95% over probability, 95%, 95th percentile. Put it on the picture. Once it's on the picture, we see what area we need. Now we take that area to the table. Z-scores live on the outside, areas live on the inside. Whether you're talking about the picture or you're talking about the table. Z-scores live on the outside, areas live on the inside. So now I need to find an area in here which looks like 0.4500. That's why I tell you should write your areas with 4 digits and your Z-scores with 2. Because Z-scores are written in 2 and areas are written in 4. Get in that habit. Eeny, meeny, I don't know. Right here. Somewhere between 0.4495 and 4505 is where 0.4500 would land. Given that we're using the table, you can use either one of those values to answer this question. The best answer here would be to use whatever Z-score is between the Z-score that generates this and the Z-score that generates this. The Z-score that generates an area of 0.4495 is 1.64. So if you look up a Z-score of 1.64, that's what you get. If you look up a Z-score of 1.65, that's what you get. If you look up a Z-score of 1.645, you get something right between them. In other words, if I look up a Z-score of 1.6, I'm going to pick 5. If I look up a Z-score of 1.65, I'm going to get an area of approximately 0.4500. And the reason I'm looking up 0.4500 is working backwards is that 95% of stuff is here. So 95% of stuff is here, leaves me an area of 0.4500. I find the area of 0.4500 in the table, and that gives me a Z-score of approximately 1.65. The last step that I need to take, I went to my table, and I got my Z-score of 1.65. Now I got to go to my formula. I can either use this formula in algebra, or algebra and then this formula. X equals mu plus z times sigma. X equals mu, which is 50, plus my z-score of 1.65 times my sigma, which is 4. Beep, boop, boop, boop. Beep, boop, 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 boop. What do you get? Drew, what you got? Something around 56.6. The answer says D. Oh, you gentlemen are missing the heart of the discussion, aren't you?
What's that?
I know you guys have to take off. I like having you around. I'll miss you guys. See you tomorrow morning. Good work today. So this is the first time we've seen this problem. We haven't even introduced this in the class yet. But it just follows the same steps that we're talking about in class, but going in the opposite direction. Let's try another one. A normal distribution has a mean of 80 and a standard deviation of 14. Determine the value above which 80% of observations occur. Normal distribution. Normal distribution has a mean of 80 and a standard deviation 14. Let's draw my picture. I have to determine the value. If I'm determining the value, my destination is over here. I better start with some proportion of probability. In this case, determine the value above which 90% of observations occur. In the previous problem, we said determine the value below which 95% occur. In this problem, we need to determine the value above which 80% of the values occur. There's a difference between the 95th percentile and the 20th percentile, where 80% is above it and 20% is below it. In the previous problem, it's determine the value below which 95% of other values occur. So we start with the proportion. We're going to draw a line on this picture. Do we draw a line on this picture to the left or to the right of the mean? To the left or to the right? We need the value above which 80% of the values occur. Over here, 80% of the values are above me. Is that possible? Why is that not possible, Jane? What?
There's a bit of variation.
Let's walk through this a little more. I'm going to put the mean here. What proportion of the population is to the left of the mean? What proportion of the population is to the left of the mean?
Half.
Yeah. And to the right? Half. 0.5 is over there. 0.5 is over there. So if I stand here, is it possible for 80% of the values to be above me? Why not?
It can be only a max.
Yeah. Yeah. More than half of the stuff can be below me, but more than half of the stuff cannot be above me. There's only like that little bit over here, but there's all that over there. Determine the value above which 80% of other values occur. I need a raw score here. I've used that probability proportion to say 80% of stuff is over there. I've drawn my proportion on my picture. Now I need an area which I can look up in my table. Given what I've drawn, I got this chunk or this chunk or this chunk. I got 3 chunks. How big is this chunk? How big is this chunk? From the mean over? 50%. If I start at the mean and a normal distribution, it's also the median. So that's going to be 50% of stuff over here. So how much of stuff is from the mean over that way? 50%. Good. 50% of stuff is here. 50% of stuff is here. Bless you. If 80% of stuff is all of this, and 50% of stuff is all of this, how much is left in this area right here? just between whatever raw score we need to find, that's our destination, and the mean. What area is right here? 30%, or 0.3000. This is why the picture is non-trivial. This is a piece of information that you need to know about the normal distribution. This is a piece of information that you gather from the question. When you combine those two pieces of information, you get the area of 0.3000, which is the value you can then look up in your table. And I come to this table, I need to find the area of 0.3000. Areas live in the middle of the table. I can't find 0.3000. I give up, I quit, math is hard, etc. Or I find something close to it. Anybody see a value in those areas close to 0.3000? Carrie, prove to me you're here. What's a value in the middle of this that's close to 0.3000?
Is it the one that says 0.117?
Say again?
Is it the one that says 0.1179?
0.1179. No. So here's the big thing that we need to keep separate. On a Z table, the Z scores are on the outside. The areas are on the inside. In our picture here, the area of 0.3000 is on the inside. So we need to find an area of 0.300 on the inside, then go out to find the Z-score. Because in this case, we're starting with an area and moving backwards towards the Z-score, not from a Z-score to an area. So in this table, somewhere in these areas, if I can't find 0.3000, I need to find something close to it.
Can it be where it's on Z, where it's 0.8, and then all the way over to 0.04?
That's right.
Because it's 0.2995.
That's real right. That's exactly how you do it. Well done, Carrie. Thanks for sticking with it. We just find a value in here that's close to 0.3000. I know I could say 0.3 and save myself the trouble of 000. But I say 0.3000 because the 4-decimal number is the nomenclature for our areas. And I want to make sure we're thinking about that and not 0.30. Rather, find the area, its corresponding Z-score of 0.84. And then I come back to my picture and I write for this is the raw score, and this is the Z-score. Z-score for the mean is 0. And then I write for my Z-score here, 0.84. Curry, what did I do wrong? Damn it, Curry. What did I do wrong? Christine! What did I do wrong?
You have to subtract it from. No, you have to. I'm not clear.
This is my Z-score of 0.84. It's,
Then you have to like put it in the formula.
we're going to do that, but if I plug that in the formula, I'm going to get the wrong answer. If I plug that into the formula, I'm going to get the wrong answer. What's wrong with that for a Z-score? All right, let's go up here. The Z-score has two parts. A Z-score has a distance, and a Z-score has a,
Oh, you need the direction.
and what's the direction? Exactly. So what's wrong with 0.84?
It needs to be negative.
Needs to be negative. That's huge right here. That's real huge right here. If I use a positive value for my z-score, when I use the next formula, it's going to give me the raw score that should be over here. It's going to give me a raw score greater than 80, which is the wrong answer. My raw score should be less than 80. It should be probably one of those two values. Because those are the only two values that you're left. That's a lot less than 80. That's probably more or less than 80 than it needs to be. In fact, based on the arithmetic, I guess that's the right answer. Because that has a z of negative 0.84. That has a z of positive 0.84. That represents the raw distance between the mean and a z of 0.84 or negative 0.84. That sounds like the way I would have written the answers to that problem. But this formula is the one we need to apply here. Being mindful to keep the z-score negative because it is x equals mu plus z times sigma. Mu is 80, z is negative 0.84, sigma is 4. 80 plus a negative 11.76 is the same as 80 minus 11.76, or 68.24.
You have signal 14.
14. Thanks, Steve. Appreciate that. It was 4 before. That's changed. Yeah, 84% of 14 looks like that. So that's your answer. Sometimes we go from left to right. Sometimes we go from right to left. How are we holding up?
If you want to use like the little like sliver, would you use like 0.2 and then find that value on the table and then?
Say again, when we start, go back a little bit.
If you want to use like the little sliver instead of,
The tail?
yeah,
We call this a tail, by the way. This does have a name. It's called a tail. I call it a chunk. It doesn't have a real name. It's actually called a tail. All right, so we use the tail.
so if you want to use the tail, would you use a value for 0.2 and then like 0.2000 and then find that on the table and then subtract that from the one?
Nope. Because this chunk here is the only area, our table, there are other tables, but our table can only manage things which do areas between, see that behind there. You know, our table can only do areas between the mean and some other value, but it can't do any tail values for areas. So if I looked up an area here of 0.2000 and I get a z of 0.52, that's just telling me that if I go over here to z of 0.52, I get an area here of 0.200, but it does not give me anything to do with tail. Okay. Question number 28. According to media research, the typical American listened to 195 hours of music in the last year. This is down from 290 hours 4 years earlier. Dick Trithall is a big country and Western music fan. He listens to music while working around the house, reading, writing in his truck. Assume the number of hours spent listening to music follows a normal probability distribution with a standard deviation of 8.5 hours. If Dick is in the top 1% in terms of listening time, how many hours does he listen per year? This is another case where we have to find a raw score. We have to find a certain number of years. What pieces of information are useful here? I'm going to tell you that it's normal distribution because right here it says follows a normal probability distribution. What do I want to use for the mean in this case? What are you saying? Yeah, 195 hours here. That's our mean, 195 hours. Now, 4 years earlier, we may have had a slightly higher mean, but right now we're talking pretty much in terms of this year. Mu is 195. The standard deviation is 8.5. We want to know about Dick Tricol being in the top 1% of all music listeners. If you're in the top 1%, view the left to the right side of this distribution. Who says left side of the distribution? Who says the top 1% is in the right side of the distribution? Hey, those hands have it. So somewhere over here on the right side of the distribution, boom. If you're in the top 1%, I have basically 3 chunks here. I have all of this chunk, and this tail. If we're the top 1%, which one of those 3 pieces is 1%? Most of you have demonstrated that you're here. Who demonstrates that they want to leave? Which one of those should be 1%? Jack?
The last one.
The last one. The tail should be 1%. Express 1% as a decimal, Jack.
0.01.
So that proportion, being in the top 1%, is now drawn on my picture. I need to find an area that my table can use based on my picture. Based on my picture, what is the area my table can use, Jack?
0.5. Well, that'd be 0.4.
0.4 what?
0.400.
A little more. How would I find what this area should be? How much is all of this? 0.5. How much do I need to subtract to find out what's in there?
0.01.
0.5 minus 0.01 gets us an area of 0.4900. That proportion went to the picture, got the area. Area, we now go to the table. Have a real call.
Thank you.
Yep. Somewhere up here on this picture, in this table, we got to find an area of 0.4900. I don't see 0.4900 on this table. I give up. Table's broken. Math's hard, etc., etc. What do I do instead? What do I do instead? Carrie, can you tell me what I do here?
Area.
Okay. So where do I find? Where am I trying to find 0.490?
What was the number?
900.
You see something down here?
Yeah. Here, pick the number.
4900.
4900. It would be the 0.4901.
That's just fine with me. Yep. So here's another thing where people are like, do you care about rounding? And I just say do it right. In this case, if I'm trying to find 4900, I have an option between that one, or that one, That appears to be closer than that one, but in either case, we're talking about 2.30123. So probably 2.33 is the z-score. In other words, if I have a z-score of 2.33, and I look up a z-score of 2.33, 2.30123, I get an area that's approximately 4,900. I'm sorry, 4,900, 14900. The last step I now need to do, now that I have a z-score, took the area, got a z-score. Let's see all that stuff. I hope it all fits. Hope it's not backwards, is it? That's over. Nope, it's recording too. I know. Mu is 195. Z-score is 2.33. Sigma is 8.5. That's about 17. And the third, that's about 3. So that's about 20. So I'm going to say that's probably my answer. It's about 20 over 195. It's really the only one of those answers, by the way, that seems at all reasonable. If the mean is 190 and the standard deviation is 8.5, 290 is many standard deviations above the mean. Many. Too many, in fact. We can stick around a little bit. I got a thing at 7:15 over in Slayton, so I will have to run around then, or just text them and tell them I'm gonna be late. I got home. People are already here at 7:30, so we may have to scoot then. Feel free, you're here on your own free will. Just trying to help. But it's for problem 29. This is down from 240 hours 4 years earlier. So if we do question number 29, we're just changing the mean from 195 to 290. Assuming you follow that distribution, assuming you follow the same steps that we have here, you can approach the same answers. Here. Question number 30, and here's how I'm speeding this up a little bit, just to talk strategy and let you do some math on your own. Question 30, the mean annual cost to attend a private university in the United States is a laughable $26,800. Everybody laugh at how old this problem is. Assume the distribution of annual costs follows the normal probability distribution and the standard deviation is 4,500. 95% of all students at private universities pay less than what amount? We're given 95%. We're going to have to work from that proportion back to a raw score because we're talking about what amounts. And amounts should be in a raw score. Those are silly answers. We have a mean, and in the middle is the mean of 26.8. As the z-score 0. We got to put a line on here, which is going to represent the value below which 95% of all people, because everybody below that line is the value that everybody pays to go to school. Whether you pay 10 grand, 20 grand, 30 grand, 60 grand. Which side of the distribution should this line be on? Left or right? Left or right? You can tell me. Left or right? Caleb?
Right.
Yep. We're going to put a line over here. We're going to say 95% of stuff is below that mark. So what useful area, Caitlin, does that provide for us? What area am I going to have to look up in my table?
Right. The area of the 95.
Yeah, I need an area. This is a useful size area that I can look up in my table. Because that's an area that looks like,
That's 45.
yep. So I'm going to look up 0.4500 there. That's something we did earlier. We know that z-score is approximately 1.65. Use the formula, get the raw score. Or look at the answer keys. The raw score. In 31, the manufacturer of a printer reports the mean number of pages the cartridge will print before needed place is 12,200. So the mean is 12,200. Follows a normal probability distribution with a standard deviation of 820. The manufacturer wants to provide guidelines to potential customers as to how long they can expect the cartridge to last. How many pages should the manufacturer advertise for each cartridge if it wants to be correct 99% of the time? We've got to provide a certain amount of pages. It's going to be a 99% thing. But the toughest part of this question is which side of the mean do we put our line on? Is it going to be on the left or is it going to be on the right? Katie, what do you think?
The left.
Why the left?
Because before when you asked what side 1% to be on, the right. So,
I can have the top 1% or the bottom 1%. The percent won't give away which side it needs to be on. This is a problem that's challenging for context. Let me run this one by you. I'll give you two equally ridiculous possibilities. So I'm a printer manufacturer. And I say, oh, somewhere over here. This is justification for the left side. I'm going to draw a value down of 50 pages. Does it pass the logical smell test that 99% of all of my printers will print for 50 pages? Let me try the other side. Does it pass the logical smell test that 99% of my printers will print 1 trillion pages? Do you think 99% of my printers will print 1 trillion pages? No. That's pretty ridiculous and pretty impossible. It would make no sense to put something on this side. However, whatever this value turns out to be, you can see from the key it's around 10 grand. It's reasonable to assume that 99% of my printers should make it to 10,000. And if a printer doesn't make it to 10,000 pages, we should probably refund that money. Say, sorry, you got something that was crappy. On average, 12,000. On average, 12,000 is what we expect. You guys sneak out. Not breaking my heart. In a little bit true. That's one of the challenges for problems like this. It's getting which side of this do you put it on. In our case, we have to set this problem up so that 99% is to the right-hand side, and only 1% is over here. And 32, that's a problem more like we've done in the past. First half questions. What percent of sales reps in 33 are between two values? This is just going from left to right. 34, again going from left to right. In 35, we're looking for a cutoff point where we've got a mean, we've got a percent, and a standard deviation. So in question 35, it says the annual commissions earned by state reps, follows normal distribution. The mean yearly amount earned is 40K. The sales manager wants to award sales representatives who earn the largest commissions a bonus. He can award a bonus to 20% of the representatives. If you're going to give a bonus to 20% of the representatives, which 20% of representatives are you going to give a bonus to? This 20, this 20, or this 20? A, B, or C? Which 20%, Kaylin, you know? Yeah. So in question 35, if we say we're going to give a bonus to a certain 20% of our sales reps, it's this 20% over here. Which means the area we use is 0.3. Let's see, does anybody have any more specific questions? Because there's a couple more practice problems in here before we get to some true-false stuff at the end. Let's see. Yeah. The rest of those problems all follow either a left to right or right to left logic for those things. Questions, comments, thoughts on those? If you have more questions, do bring them up. Give me 2 seconds to see what's happening out here. Carly, you got 7:30, right? Or you 7? 7:15? All right, give me 2 minutes.
Okay.
And then I'm out. So, we got to get out of here in 2 minutes. These true-false questions, which will close out the day. And there's 2 at the end. Do these real quick, please. If you're awesome, be awesome. When referring to normal probability distribution, there is not just one. There is a family of normal probability distributions. There is a family of distributions? True. A group of normal distributions can have the same mean but different standard deviations. Which one?
True.
True. True is right. The standard normal distribution is a special normal distribution where the mean is 0 and a standard deviation of 1.
Sure.
Oh, yes, 44 is true. Sorry. 44 is true. The standard normal distribution is a special number. That's its definition. 45. Z-scores for X values greater than the mean are negative. True or false? False. False. If you're greater than the mean, you get a positive Z-score. A couple of things that we should know about the normal distribution. The mean divides the distribution into 2 equal areas. Because the mean is also the median, and that's the median's job. And in 42nd, 2 normal distributions are compared. One has a mean of 10 and a standard deviation of 10. Second has a mean of 10 and a standard deviation of 2. The dispersions of those 2 distributions are different. So sorry we couldn't make it through all the problems, but hopefully you've got enough in terms of practicing the different types of problems to model the rest of them that we need to do. And if you have more questions about specific homework problems, don't be scared to ask them in class or send them via email, and I'll do my best to get responses to you. If you got last minute questions, let me know. Caitlin, yeah?
Back with like 26 and 27 and stuff, I'm confused why you didn't add another like 0.5 to those values, like when we did the 0.3 and stuff.
26, 27?
Yeah.
All right. Katie, what's the question?
Is it still due tomorrow, or?
You can have a couple days if you need a couple days. That's fine. Yep. Carly, if you guys want to start filing in, we're filing out. You just got one question answered. So back here,
Yeah.
what's the question again?
Like, we found the z-score for 0.30, and then I don't know why you wouldn't add the other 0.50 if you needed 80%. Like, why you wouldn't add 0.5?
Because the thing I need is just this part. This is the part what I'm referring to for area. Because I just need the area to get to the z-score.
Right.
It's because I don't need anything else. Sure, all of this is 80%.
Mhm.
And that's great because it's 30% plus 50%
Right. But you just find that z-score for that one.
right here. Yeah.
Right. Okay.
'Cause that's the only part I needed. I actually had to subtract this 50%. I started with 80%. And I subtracted that 50 to get me this 30. And this 30% is what I used for the z-score.
Right. Okay. Thank you.
Mhm. Y'all are in here at 7:15 too? Or?
See you tomorrow.
Yeah, see you, Caitlin. See you.